be 2x over xy plus 4 over x squared minus 3. The first thing I do is I make everything a rational expression. So I would put that over 1. Because remember, I'm trying to get common denominators. The first step is to factor your denominators. But when there's no adding and subtracting, it's already factored. Here's your factors. This is an x, this is a y. Those are your two factors for that one. This guy, if you really wanted to, it's its own factor, or you can think of it as it's an x and an x. You see how I put the brackets? It's an x and an x. And this one's got a 1, which really doesn't matter. So now you're already factored. What is the greatest or the least common denominator you could use? How many x's must every term have in order to satisfy each one of these? You must have 2, because this guy's got 2. Do you see that? So this one needs a second, and this one needs both of them. Okay, do you see how this guy's got a y? So this one needs one as well, and so does this one. And then we don't worry about the ones. Okay, so the x's, the minimum you have to have is 2 because of this. So I'm going to times this one by an x over x, so that it has its 2 x's. Same with this one, I'm going to times it by an x and an x, or you could just put an x squared, it's up to you. Okay, what's the middle term missing? What's the middle term missing? So we've got our x's covered, every single term has x squared in it now. It's missing a y, good. Now my first two terms have the same denominator, they have x squared y, x squared y. My last one is missing the y. Now they all have as their denominator x squared y. Okay? So my new numerator here would be 2x squared over my x squared y. My next numerator would be 4y over x squared y. And my next one would be 3, it's got a minus though, x squared y over x squared y. Now I have all common denominators, so I can add or subtract my numerators as needed. Okay? So my numerators will be 2x squared plus 4y minus 3x squared y, all over top of that common denominator. Okay, now this one here, order doesn't, it's hard to do order here because our order usually goes x squared, then x's, and then no x's. But two of my terms have x squareds, but they can't be combined together because one's x squareds and one's x squared y's. So they have to stay separate anyway. So I'm not factoring it like a normal trinomial. So this question's actually done. Oops, I made a mistake. Where's my mistake? I got a plus sign there. Yeah, x squared y it should be, not x squared plus 5, right? And then the only way, like I was saying, we can't factor my numerator, so the only way that it could cancel is if there was a greatest common factor that came out of the top that was the same as the greatest common factor that came out of the bottom. But on the top, there's no greatest common factor for 2, 4, and negative 3. And I can't take an x out of every term because the middle term doesn't have an x. I can't take a y out of every term because the first term doesn't have a y. So there is no greatest common factor that could come out. If there was, I would see if that item could come out and reduce with the denominator. But this question's done, other than I need to state my restrictions. X, comma, y, so both of them cannot be 0. Okay, and remember, that's because technically these down here are an x minus 0 squared and a y minus 0 factor squared. So what makes those 0 would be